So welcome everybody. Thank you for joining us at 9 a.m. on Saturday morning. We are about to hear Why is Biochar Called a Miracle for Plants and the Planet with Debbie Cook. And as you may have read in the program book, Debbie discovered biochar while she was working at the North and South Rivers Watershed Association as communications director and statewide coordinator of Greenscapes, a land care program. Since then, she has been on a journey to learn everything she can about this amazing substance, including a 6-week trip to the Amazon, where she lived with the Quechua people who may have invented it 6,000 years ago. Her journey has taken her to COP22 in Morocco and to Washington, D.C., where she made a presentation to Senator Markey's office. So I'm going to give you a few more announcements before Debbie takes over here, but we're really looking forward to this workshop. Oh, how do I advance my slides here? There we go. Okay, and as you will hear us announcing in each of our workshops, we just want to acknowledge that we are presenting, attending, and hosting this workshop from land that was managed and inhabited before European colonization. So please take a moment to find your location on this map, which Christine will put in the chat, and honor those whose land you now occupy. I think we've all spent plenty of time on Zoom in the past year, so you probably don't even need this slide anymore, but you probably noticed you were set as being on mute when you entered, and if you want to unmute, you probably know how to do that. There's a little microphone button at the bottom of your screen. If you're not talking, please do stay muted to avoid background noise. And we do invite you to use the chat feature throughout the workshop at any point if you would like to ask questions. We are going to wait until the end probably to take the majority of the questions, but sometimes people like to put their questions in the chat as they go along. So feel free to jot down your questions as we go, or just wait till the end. Either way is fine. I will keep an eye on the chat, and Debbie will answer your questions at the end. And also, I just want to note that this session is being recorded. And here's another slide you will see a lot this weekend. As you know, we do depend on a lot of sponsors for our conference each year. So these are our gold sponsors, and we encourage you to support all of these businesses that have helped to support NOFA this year. And these are our silver sponsors. Christine will put a link in the chat. If you haven't checked out our summer conference auction, there's some really excellent items there. You can go check that out in the break between workshops. We'll have a little break between 10:30 and 11. So you can go check that out and bid on any of the auction items that you're interested in. And we also have virtual vendors, and this year they also, you'll see like little videos embedded into the program book. So it's sort of like walking by and talking to them in person, but you get to hear from them in the program book. So you can check those out as you leaf through the program book as well. So I think that brings us to the end of our announcements, and I won't take up any more of your time, Debbie. I'm going to hand things over to you.
Okay, great. All right. Well, welcome everybody. I am very, very excited to be here, and I am going to start right in. So I'm gonna. So what I'd like to talk about is biochar, a miracle for plants, people, and the planet. As they said, I discovered biochar when I was working for the North and South River Watershed Association. That was about 7 or 8 years ago. And I kept thinking, how can this, I kept reading about this miraculous substance that no one seemed to know anything about. And basically I thought, this is too good to be true. So I began an exploration about it and found out from some very, very prestigious sources that it is indeed everything that they say about it. Okay. So first of all, I'll start out and I'll say what is biochar. Biochar is it's actually almost pure carbon. And the beauty of it is that it is filled with pores, which allow it to be almost a condominium for microbes. And also it can store an amazing amount of water. So down here, if you took all the pore surface area of just a 1 gram of biochar, which is, just a little bit in the palm of your hand, and you took the pore surface area and you spread it out, it would cover 2 tennis courts. So if you could imagine, that folding and folding and folding in a stable form of carbon, it is a very powerful, very, very powerful. So biochar was invented 2,500 years ago in the Amazon. There's a lot of dispute. I've heard up to 6,000 years ago in the Amazon. But it was only discovered about 40 or 50 years ago, uh, uh, what it really was. It's the glue that actually holds the fertile, famous terra preta soil together, and it's the key ingredient that makes the Amazonian fertile soil. Now, I don't know about you. I was taught that the Amazon, the soils were very poor. It could only support a very small amount of people. But actually, thousands of years ago, up until about 500 years ago, it supported millions of people along the Amazon. So the first explorers that went there found a very, very rich culture. And, and they wrote about it. But when the next explorers came, they found a very diminished culture. And there was, it was poverty. There was no people left. What happened is the first group came through and brought smallpox that killed about 98% of the people and left the rest in complete disarray. So their knowledge of biochar, and also their knowledge of amazing things like the concept zero, writing, the wheel. uh, Archaeologists have found that they had all of those things, but they lost all that culture due to the explorers that brought the smallpox. So one of the things that the explorers left were iron tools, and they had to resort to slash and burn agriculture, which is what they use today. And as we all know, slash and burn agriculture is just about maybe a 1 or 2 crop season, and then the soil is degraded and they move on. And so basically, that's what was happening in the place that I went. I went. Frederique Apfel Margolin was the woman who organized the program that I went on for 6 weeks in the Amazon. And Frederique is a really interesting person. She is was a sociologist who was studying the Quechua people. And she realized that they could no longer live on their land because the soil was so degraded. And she said, if I'm going to study these people, I am going to have to try to do something to save their land. And so she discovered biochar, their ancient substance that they have been credited with creating. And she said, I'm going to bring that back. And so she created an incredible program. And so we went to this place she founded called the Sachamama Center for Biocultural Regeneration. Biocultural means both the culture of the people and also the biology. We went to a place called Lamas, which is called in the sort of the high plains area of the Amazon, kind of up in the very beginning of it. And it is very, very degraded area. And so what we did while we were there is we made what they call Yana Achpa right here. Yana Achpa is the Quechua name for the terra preta black earth. And these are the components. I'll go over them. This is in Quechua, and this is basically we collected cow dung. Now, it was really interesting. I'll talk more about that, but that's sort of the organic material. Because if you think about the Amazon, there's very little organic material. We had compost, and then this kana. This is the limestone and minerals we collected. This is biochar, the glue that holds it together. And then this is the Sachininichi, which is a nut that gave it also organic matter. So what we did was we went out, and this is Frederick right here. We collected cow dung. Now, of course, cows are in recent times. So we were trying to think, what did people have? Back in 6,000 years ago, there were no cows. There was, really virtually no animals except for some howler monkeys and, things like that. And we discovered wherever the terra preta black soil was, the archaeologists had discovered that there were pottery shards. And so while we were there, archaeologists had kind of put two and two together, and they announced that they figured those pottery shards were human waste, so that they were collecting human waste to mix with the biochar that they had made, and then with the other things to make the terra preta black earth. So here we are collecting the biochar. David has a whole package of cow dung on his back. And here is Jed. He is making compost, which is another really interesting thing too, because there you would think that in the Amazon there would be a ton of leaf litter and and a lot of organic material, but there wasn't, because the leaf cutter ants and the surface life would destroy the leaves almost as soon as they fell. So basically, we had to make compost, and we used obviously our things from our kitchen, and we did collect enough leaf litter and put it in. I mean, it has to be done man-made, just like they did 6,000 years ago, or up to 500 years ago. They had to collect that because it didn't occur naturally on the soil. So here we used to travel around in a safari-like truck and go over, roads were literally piles of rocks and mud holes. And so we went and collected rock fragments. This was one of the hottest days that we had, and we were out there, must have been 85 or 90, and collecting the rock fragments, which, as we all are learning, minerals are a major part of soil health. So now I want to talk about the biochar part. And so biochar is man-made. It is, if there is a fire, maybe 4% will end up being naturally caused, naturally created by a fire. But for the most part, it is man-made, and it's made through a process called pyrolysis. And that is, as it's burning organic material at high heat without oxygen, or with very little oxygen. So it's obviously something, when you think of a fire, it's loaded with oxygen. I mean, and that's why what we get with ash or even charcoal is very different. If you can always tell if something is biochar, because if you hit it against your teeth, it makes a clinky sound, and it's a much more stable material. So basically, biochar, you start with biomass, which is where you get the photosynthesis, and then you take the biomass and then you put it through the pyrolysis process. There's a lot. I'll discuss some of the processes later on, because there's a lot of different ways doing it, very primitive to very high tech. And you end up with three byproducts. Besides biochar, you end up, here's the biochar, which is permanent carbon sequestration. And you also end up, as you're making it, with energy, biofuels, and you can get wood gas, which is actually wood vinegar, which is actually a very high powered um, organic material that you can use as a fertilizer. So, and then 50% goes off back into the atmosphere and comes back in photosynthesis. So it's that is basically the biochar process. So here is Frederique. Now she invented, this is her biochar maker. This is actually a double kiln. But what she would do is we would load this top part up. I'll show a few more slides, and with coconut hulls. And then down here we would use wood, and we would heat the wood up to such a temperature that the corn, I mean the husks, the coconut shells would actually almost spontaneously combust, and there would be such, they would cook. So I'll show you in some more slides how that would work. So here we are loading this, and this is the top, putting them in. We're going to seal that up. And then down below, we put in the wood to start the fire. Here's the fire down below. And then, and you can see we had dual ones going. And in about a half an hour, we would be done. And now there's some pipes behind here. This is where, like the wood vinegar would be created. And if you were going to siphon off the heat, there was tremendous heat in here that you could get. And so after about a half an hour, this would be ready to bring out the very hot coals. We would take the hot coals, dump them all out, quench them with water. You have to stop the process right away, or then it would burn down to ash. And then we took all the things we collected, the nuts, the minerals, the cow dung, the biochar. We mixed it all together into a big pile. And we would turn this pile once a day for a month. And I'm telling you, this pile got so hot, it just absolutely steamed. It was so full of, vitality, life. It was just amazing. And that was the terra preta. And then basically we would go out. These are some of the Quechua people. And we would go out and put it in the soil, and then we would have a planting ceremony. And this is chicha. This is a fermented, they had made a fermented corn drink that they would drink and then pour on the soil to honor the gods that gave the soil fertility. So I'm going to talk about, why biochar is a miracle. But first of all, I'm going to tell you what it does, and then show you some examples. So like I said before, all those pores, it fights drought. It can be such a reservoir to hold water. So here's an example of biochar corn. with just, added biochar, and then here's plain soil. It makes plants healthier because it also, it increases the soil fertility, and basically it holds a lot of the components of soil together. And for me, one of the most important things is it combats climate change. And we'll discuss that more too. But it's pretty powerful what it can do to combat climate change. So this is just a little example in Norwell, of a guy I know that tried biochar. And so this, I think you can tell which one has, these were exactly planted the same. So this is without biochar. This is where his tomatoes ended up, about this high. This is his tomatoes with biochar. So you can see the lushness, of this sort of, I wouldn't say it was a scientific experiment, but it was, the only difference between these two beds was biochar. So talking about how it makes the soil more fertile, the terra preta soil with biochar has more nitrogen, phosphorus, calcium, and total organic compounds. And this is an example of the normal, this is an example of the normal Amazonian soil. I mean, there is just no way that the um, roots can penetrate this. This is just, it's clay. It's really awful. And this is what slash and burn agriculture is now causing. So here where we say biochar makes plants healthier, this was an experiment at the Morton Arboretum Soil Science Laboratory, probably one of the most prestigious laboratories there is. This is obviously, this is without biochar. This is with biochar. Root growth of honey locust seedlings in compacted soil after 18 months of no treatment on the left and an application of biochar. Top dressing on the right. Speaks for itself, I think. There's a lot of evidence about how it fights drought. This was an Austrian experiment. And basically here's, with no biochar, this sort of tracks the seasons and the holding capacity of the soil to hold water with no biochar and with different levels of it. And biochar fights climate change. This is pretty critical stuff here. So the biochar, the regular carbon cycle, as we all know, this starts out with the photosynthesis, and then basically the plants die. They decompose or they burn. The carbon enters the soil, and then it is basically released back up into the atmosphere, and it just goes round and round. And where we got into problems was, there was so much held in the soil that wasn't ever part of the carbon cycle. It had been held in the soil for eons as that we have extracted for oil and gas. So we have completely disrupted the cycle and added so much more into the actual bringing it into the atmosphere. If we hadn't done that, the cycle probably would be able to continue and be in balance, but we have completely messed that up, as we all know. So with the biochar, what happens is you can take 50% of the carbon out of the cycle. So when the plants die and you use the material, 50% can be locked into biochar. And then the other 50%, this is really the cool part, You can use the byproducts in this part, the syngas or bio oil, use energy, so you actually get a lot more out of this. And then 50% goes back up into the atmosphere. And so we're extracting about 50%. Now, I know a lot of people are very concerned about this aspect here, about the biomass, and they're very afraid about, people growing trees and then wholesale cutting them down. And I think all biochar advocates that I know are very concerned about using damaged, dead, materials, and really controlling where this comes from. And so basically, we nobody wants this. And I think that as things go forward and there's more demand for it, we're going to have legislation about how it's how it's packaged and where it's accessed from. But all around us are dead ash trees, and there's a lot of fallen material from these wild storms we have, that potential biochar out there. So an amazing fact: 1 pound of biochar removes 3.7 pounds of carbon dioxide from the atmosphere. This is in the best circumstances. Generally it's probably more on the order of maybe 2 pounds, but it can, if you do it, everything is working right, that is the potential. And that is a pretty astonishing fact. And when it says it removes it, it doesn't obviously remove it directly, it offsets it. And then you can lock it in the earth where it works its magic. So here we are again, with the cycle. So how to make biochar can be made at different scales. It can be made at very basic scale, which is a T-Lud, which is a top lit updraft cook stove. So these are very something that you could get for your yard. I'm going to show you an example a little later of, I've actually bought one, and we could talk about it. There's greenhouse, scale heat, where people have actually heated, they put these here and then they can heat, I know people who've heated lumber drying facilities or greenhouses with biochar. You can heat buildings. Then there's some big operations, continuous feed ones, and so they have those. So you've got pretty big, massive ones. I will say China's building, or at least was building, a large biochar plant a week. I'm sorry, I think it's more a month, because they have recognized the value of biochar for their soils, and also as carbon offsets for all the things that all the destruction they've been doing. But so here is an example, which I bought one, Blue Sky Biochar. This is just something that you can get. It's called a fab stove, for $199. A friend of mine was part of the inventing of it. And it's a cool little thing, because up here is, you could see, you could put a stove, like a little, pan on it. And so you can cook, heat up water or whatever with it. This is a solar starter. So basically you load this with wood pellets. Now I bought a little electric wood chipper. So I fill mine with wood chips, and from sticks that I've collected from my yard. or out in the back in the woods. And then, you know, basically you cook it. You can boil the water. It's a fun little thing for dinner, and then or camping or whatever. And then you've got the biochar. So these are available. It's just, you know, the T-Lud clean cook stove. This was they're using these in Africa, and actually, I will talk about this too. The guy who was inventing this, he has also invented this thing called a rock kiln, which he is now working with, and I'm helping him on this. Fund a guy in Kenya who is building these rock kilns that rotate, and basically he builds them out of barrels, old, you know, oil barrels, and he uses bicycle wheels, and has you know, it's kind of a cool thing. So he's doing this. It's just a fledgling business, but he's hoping to, if it's successful, bring it to Venezuela and India and different places, so that the local people can use these things to make biochar. There are other people doing similar things around the world. So this is these are, I think, some interesting comments about it, biochar, and I do want to sort of take the time to look at them, because Johannes Lehmann is probably one of the foremost soil scientists in the world. And he said biochar can be used to address some of the most urgent environmental problems of our time: soil degradation, food insecurity, water pollution from agrochemicals, and climate change. And Dr. James Hansen, who was probably one of the first to blow the whistle on climate change, he said biochar can be used to restore soil fertility while storing carbon for centuries to millennia. Bill McKibben, who I think we're all familiar with, he said, if you can continually turn a lot of organic material into biochar, you could over time reverse the history of the last 200 years. And Peter Reed from the Massey University said it has been found that with some soils and crops, productivity can be increased 8-fold. For the atmosphere, that's a treble whammy: fossil fuel left in the ground, stable biochar carbon in the soil, plus increased labile carbon bound up in the life cycle of the greater weight of crops and their in-soil roots. This is for anyone who wants to go, you know, learn more about it. The International Biochar Initiative is kind of the go-to place. It is an amazing group. It's international, and you'll realize that there are groups all over the world. And there's also a lot of Facebook groups from Africa that I belong to, and Australia, and there's, you know, some real people are really obsessed with this. I you know, they, once you get involved, you know, and you can become quite obsessed with it. But the International Biochar, they published a list of studies or that have been made all over the world. There are probably 300 to 400 a month that you know, in the universities, just, you know, finding out about biochar. Um, and so it's a very good resource. And this is the chairman. This is a distorted picture. She doesn't really look like that, but I wanted this to be, this just came out, I think, yesterday. And I just wanted to put this out here because she wrote, Fortune magazine wrote 2 articles on biochar in 1 month. Microsoft and our other large multinationals are now promoting their purchases of biochar as a durable carbon removal product. It seems that with every passing day that biochar is getting more and more attention from a broader, more diversified group of stakeholders. So this is the planet, and biochar can help heal it, but we got to get going about it. And biochar is a miracle. And before I end, I want to talk a little bit about um, some of the constraints about biochar. And, I really can talk about this forever. But, biochar it's tricky. I mean, I'm talking about all the good stuff about it, but but biochar has constraints, and it needs to be made regionally because you don't want to transport materials great distances to burn them. Obviously that's counterproductive. So you want local facilities to make it. And also biochar is um it's not like making a Nike sneaker that you can have quality control necessarily. You're using different materials. The different conditions happen during a burn, so it's never exactly the same. So I think people have to understand that and the quality control can be somewhat of an issue. So I think, there are people who say, just go do it. And that, but then there, if people are, farmers want, quality control, there are people that are selling it, that sell it, and they have it on larger scales to put on fields and things. But if you're a backyard gardener, you can make it yourself. You can control what you're doing, or you can go buy it. You can find it from places like Wakefield Biochar, but obviously that's got to be shipped to you. And once again, the regional aspect is the important thing. Ideally, it would be great if there's larger like local composting facilities with an associated biochar place, so that people could bring wood chips and biochar could be made and then put in the compost. And that is the other thing that makes it very tricky, is that biochar is I'm going to go to the next slide for questions, because biochar is very powerful, and you cannot put it just raw in the soil. It has to be actually filled. Those pores have to be filled with water and microbes before you put it in the soil, because if you can imagine, if you just put it in the soil, those microbes and water that's in the soil will migrate there. So what you want to do is put it in fully loaded. And that's why when you're using it, you want to, if you buy it raw, just plain biochar, you want to put it in the compost uh, pile for a couple of weeks and let those microbes grow and fill with water, and then you're good to go to put it in the soil. So that is my presentation, and any questions with anybody?
Debbie, I have a couple questions. First, thank you very much for your presentation. That was so informative, and I really learned a lot. And one thing kind of related to your last part of the question is whether biochar can cause a change in soil pH. And so is that kind of mitigated if you put it in with compost, or does it change it very much?
It can change it, and it is something to be aware of. So, once again, if you do put it in your soil, I mean, we should probably get our soil tested, every couple of years anyway. So it is probably a good idea and make adjustments. That is one area that it can make a change. Generally not a drastic change, but it can affect it a little bit.
Thank you, Christine.
Sure.
Before we open up to further questions, I'm wondering, Debbie, if you want to put your contact info in the chat for us, and that way people can have the option to save the chat, and then folks can also start posting their own questions in the chat if they'd like to. And I'll also make this announcement so I don't forget at the end. If anybody wants to save the chat at the end, there's a little 3-dot box in the bottom right of your chat, and you'll have the option to save the chat at the end of the workshop if you want to do that.
Okay, so I'll just get out of this then.
Yeah, you stop screen sharing and just, either now or at the end of the workshop, give folks your contact info in case they have further questions and they want to get in touch with you.
Okay, all right, I'll put it in the chat in just,
Yeah.
or do you want me to, you want to open
You can do
it
it at the end.
gallery?
I
Huh?
think it's fine to do it at the end. Go ahead. If you want to stop screen sharing, and then at the end, you can just share your email for people. Thank you.
All right.
Great.
All right.
Thanks, Debbie.
Yeah. So I will take questions. I guess we could do it either way because it's a relatively small group here. If folks want to type any questions into the chat, I can read those out loud. Or Debbie can just answer them directly. And also, if you want to just come off mute and, turn on your video, you can ask your question directly too. Either way is fine with me.
Hi, Debbie. I actually use biochar in my garden. I was wondering, is there any way to reduce the impact while you're making biochar?
Reduce the impact?
Yeah, I was just wondering, is there a way to avoid making too much carbon dioxide while making it?
Well, basically it is a negative emissions. So actually the carbon, no, I mean, you will be releasing carbon dioxide, but it's considered negative emissions. As a matter of fact, Elon Musk, I don't know if you know about his X Prize, but if you know about his X Prize, that's $1 million prize for carbon sequestration, best carbon sequestration ideas. And they listed about 5 or 6 different sources that would be probably very good ways to do it. And biochar was one of the top 5 best sources. So it is, yeah. So
I use bootstrap biochar to seek stuff from China, and I was just wondering. I was watching videos and was really curious that he found a way to reduce it a little bit. So that's thank you.
great.
Thank you. Other questions for Debbie? I'm wondering if you could address a little bit sort of the cost to folks, on different scales. And, it's one thing if you're a backyard gardener versus if you're, really farming on scale, and just talk a little bit about sort of the cost benefit analysis and how folks can deal with that.
Well, what you're talking about is something we're all grappling with. It's a tough, the economies of scale are very tough because of the regional aspect of it, because it can be fairly labor intensive. There's a lot of, and catch-22, do you build a big facility, but then what if nobody uses it? And people have tried that, and so my idea, my presentation to Marky's office was that we should start with, basically getting a big infusion of money from corporations, especially companies that want to mitigate their carbon footprint, and especially like oil companies, and really, start from the top down so that you can create a steady supply of it, build facilities, have a steady supply, and then people can start, using it on their fields and other businesses. The American Society of Civil Engineers said it is the best toxic waste remover there is. It's cheaper than activated carbon and other things. So I have a friend who has a very polluted pond in Newport, Rhode Island, the most polluted pond in all of Rhode Island. And the state is coming in and stringing bags of biochar in the pond to take out all of the toxins in the pond. And so that's another use for it. So there are a lot of commercial uses for it, but the problem is scaling it. It's just got to have an infusion of money. And that's why it's successful in China, is because the government's doing it. The government is building the facilities, and then people know they have a steady supply, and then they can, adjust accordingly. But it is, so it's a catch-22. Nobody can get it to scale enough to make it cost effective enough. So but that's why the Microsofts of the world, it's starting to really swing towards them realizing about this and wanting to use it as carbon offsets, and starting to put the money in so that it would allow the facilities to be built. It's got to be built from the top down. Otherwise we're going to still be doing those little TLETs, which are great, and make a difference. And certainly it's a lot cleaner cooking because they don't give off smoke. I forgot to say they're pretty smokeless. So, it's cut asthma levels in the countries that have used them in like Central America. It's cut asthma a ton because they don't smoke. And so, most of the world still uses wood for, for burning, and charcoal for cooking.
Yeah, great. Thank you. And just a quick follow-up, and then we have a question actually have two more questions in the chat. But for folks who are just sort of smaller scale, maybe backyard gardeners, what would be a good source if you live in Massachusetts? I think a lot of our participants are coming from Massachusetts, although we're all over the region, really. Do you have any suggestions for where folks could purchase like small scale amounts?
It's really tough. It really is tough. I mean, a couple of nurseries I know have carried it, and, but nobody knows to go in and ask for it. That's the other problem is that, so I sell it myself. I've got, you can buy a pound bag from me for $5, and I can send that to you plus shipping, which is really, cheaper than you can get it from, if you go online and get it from Wakefield Biochar or whatever, it's more expensive. So it's once again that catch-22. Nobody's incentivized to educate people to buy it. It has to be done top down so that people know that they've got the supply, and then they'll be incentivized to educate people, and then drive the demand. This is not like demand driving supply. It's almost like the supply has to drive the demand. And so it's, hardly anyone. When I found out about it about 8 years ago, I worked for, with scientists, soil scientists and water scientists with all over the state, and no one had heard of it. So, it's big in research in universities, and it's kind of got stuck there, and they've just been studying it up a storm, but they haven't figured out how to, or they're not incentivized to get it out in the public because the supply is hard. why educate people if you can't get it to them? And so, so basically what I'm trying to do is educate people so they'll start asking for it, and hopefully maybe, people will start supplying it. But it's difficult. But Lowe's, will have it, but you have to, I think you have to contact them and then they'll bring it into their store. I mean, it is even in places like Lowe's and things like that. But as I said, nurseries have had it, nobody asked for it, and they stopped carrying it.
Yeah, interesting. Okay, thank you. So we have a question from Karen, who's asking, what happens to the biochar after it's used for toxic removal?
I think that depends. I honestly don't know whether they bear, what they're going to do with it. For example, in that pond, a lot of that it's a lot of organic toxins. So I think probably a lot of it could be buried without problems. It's the algae blooms that are making the lake anaerobic and stuff. So some of that stuff can come out. But then like the American Society of Civil Engineers said that all highways should have it on the side of the highways for not only pollution but also to collect stormwater. So and then a lot of towns are using it with their tree plantings or in urban environments to for the trees to not only collect the toxins but hold the water for the trees. So the answer to that question is I think it really depends on what it's collecting and how you would, if it's collecting things like heavy metals and things like that, then it would be disposed of the way you would anything that you're collecting heavy metals. But it is really being used. It's actually now being considered for building materials and cement. And we all know that cement is a huge carbon emitter, and they're now talking about using it in cement to offset the cost of, I mean, the carbon emissions.
Oh, interesting. Great. Karen, do you have any feedback that you'd like to add, or should I go on to the next question?
Go on.
Okay, great. Yeah, I want to give people a chance to speak up if they want to, because it is a small group, but I'm happy to move on to Vivian's question here. Vivian says, could you please share info about any towns in the Northeast that are developing local or regional biochar initiatives? My apologies if you discussed this earlier. I joined late due to computer glitches.
Sadly, I don't know. There's the Northeast has a very, I don't really know of any on the Northeast. The big areas where it's, going gangbusters is up in the Seattle area and the California area. And then there's some happening in Colorado. And there's just big groups out there. And there's a lot of people in the Northeast that are very involved. We've got tons of what I call the biochar gurus here, but they're all doing different aspects, but I don't know if towns or formalized groups. And so, so that's unfortunately that I don't know, but I certainly can, connect to, there's just lots happening. And if anybody wants to help, I'm going to get involved with doing some fundraising for the Kenya effort for Gilbert Mwangi, who's making these rock kilns out with the with I think they cost about $60 a piece with his found materials that he's going to use and bring to different towns in Kenya. And the thing is, it's almost like the third world, because it's scaled and it's seems like it's more receptive there, because everything is done on a smaller scale. Their farming's on a smaller scale. They can do everything, it's so I'm sort of thinking that that's where a lot of we can still get a lot of bang for the buck there and help their very degraded soils. And I'm also involved. There's a group in Thailand called Warm Hearts, and he's doing a lot in Africa and in Thailand with making biochar. So a lot of these people are really, doing it on a small scale. But New England is, it's just not that same kind of environment, really.
Yeah. And Vivian has a follow-up. Vivian says, thanks. Any smaller towns or regions that are good examples in Seattle area, California, or Colorado?
Well, there's different groups there that are, that you could connect with. And, I can give you some names, but there's a woman out in Kelpie Wilson who's doing, a lot of work. The Sierra Club out in the West Coast in Seattle is doing, a lot of work. So, so basically, townwide, it's more these groups that are doing a lot of work. So, so that's what I would recommend. But you can find out a lot of that on International Biochar Initiative. On that website, it will tell you what all the different groups are doing. So it's such a repository of amazing information, and that is the best connecting source for individuals, companies. It's got a lot of corporate members. So I would start all information searches there.
Great, thanks. So we've got a question from Kevin. This could be a big answer, but I think you've maybe addressed a little bit of it. How can I raise awareness for biochar?
Oh, what I love that question. I love that question. I would share any, PowerPoint, or if somebody wants to, talk to groups, or, just reach out. I mean, I'll share anything. I mean, it's just such an important thing. And, it really is one of the only and best ways to sequester carbon and fight climate change. And there's groups, 4 per thousand, which when I went to Morocco to COP22, I went with the indigenous people of the Amazon who were involved with that. It came out of France, and they're really big into, using biochar with soil regeneration to get 4 parts per thousand of carbon back in the soil.
It's 10 o'clock.
So, so basically that is, yeah, I mean, there's just tons happening all over. It's just nobody knows about it. But, so I'll share anything.
Go ahead, Jocelyn.
Yeah, I was just wondering if you could repeat the website that you mentioned.
Oh, the website, the International Biochar Initiative?
Yes.
Yeah,
you.
just Google that. Initiative.
Great.
Yeah, yeah. It's also known IBI, but other things come up with that. So International Biochar Initiative. So yeah, I can put that in the chat.
Thank you.
Okay, let me see.
And we do have another question here from Vivian when you're ready.
Yeah.
Vivian says, our town will be doing a food system plan next year, and I'd like to be sure to include biochar in our research and report.
That would be wonderful. I'll help in any way, you know, if however I can. You know, that would be wonderful. I mean, it would be so wonderful to see, you know, towns that do composting, you know, have a biochar facility next to them, and, you know, let people in the town, you know, maybe do town burns periodically and then mix it in and let the people take it home. I mean, there's just, because it just kills me to see, you know, companies like, you know, the tree companies come and chop up all the trees and then take those chips and let them degrade, you know, when they could be made into biochar. So, and I will say, I don't know if you all know the Bartlett tree experts. They're pretty well renowned. I mean, it's sort of a famous national company, one of the most, and actually it was Kelby Fight, who was the lead researcher at Bartlett Tree Experts, who said to me, you know, he had done 8 studies on biochar, and he said, you can call it a miracle because we do. And they use it with all their tree plantings at Bartlett Tree Experts. So,
Nice.
so hopefully tree companies will do more with this too.
Yeah, thank you. Quick note from Vilma, says, just an FYI, the first time I ever heard of biochar was when I began my worm bin. Many sites promoted it as worms love biochar.
Excuse me?
It says many sites promoted it as worms love biochar.
Worms love biochar. You know, I frankly don't know much about that. I know microbes like it, but like, because it's like a house for them, I don't know. I don't know much about with whether worms would. They like the fertility of the soil. I mean, you'll find, you know, if you've got a rich organic soil with biochar in it, you know, it'll they'll like that. But I don't know if by itself they'd like it. I don't know.
Okay, thanks. I'm going to turn things over to Christine to either ask her own questions or if she wants to take questions from the chat, either way.
Sure. There's a question from Patrick who just logged onto the call, and he was wondering if there was a discussion about how to best ensure the toxicity of some of the biochars avoided, and also wondering about the electrical soil conductivity that could be caused by adding biochar.
You know, that is more above my pay grade. You know, a lot of those things about the real technical aspects, this is where, you know, the studies that keep going on and on about, you know, electrical conductivity and, you know, the toxicity. I mean, that also is, you know, part of the whole process. I mean, it's also your source material and, you know, the how you do the pyrolysis. I mean, technically, if it's a clean pyrolysis, there shouldn't be much toxicity. I get a lot of biochar from a guy named Hugh McLaughlin at NextChar, and that actually comes from a wood burning plant in New Hampshire. And so basically the wood burning plant gives, you know, he's really known for testing and quality control. And he said that so, you know, there's doesn't seem to be toxicity from even a wood burning plant. So it does depend on all of those things.
Patrick, do you have a question or you want to follow up, or is that good?
No, thanks very much for the response. Yeah, I know that's a pretty heavy technical question, and I think it's kind of still under debate anyway. So if I find out something about it later, I'll send you an email.
Absolutely, absolutely. That would be, I mean, there is so much floating around about, and that's why 200 studies or more are done a month, because everybody is, you know, looking at different aspects, looking at different source material, looking at different pyrolysis temperatures, slow, you know, is it slow, a slow burn at different heats, and you know, it's so it can get so incredibly technical, and that's why, you know, it's very hard to, it's not like Nike sneakers that, you know, there's any uniformity really, because it is a natural, I mean, it's all the factors vary from burn to burn, basically.
I do have one other question if you have time for another one.
Sure.
Um, so on my small organic farm that I'm starting here in Acton, Massachusetts, I need to really work on soil porosity. So I wondered if you had any information on the ability of biochar to improve porosity and water retention.
Oh yeah, well there's a lot of information about that, and it definitely does improve porosity. I mean, obviously, because it's, you know, with its pore structure, pore PORE structure, and it's it, and also its water retention capabilities. It basically, there is a guy on the Cape, and he became a biochar guru, Bob Wells, and he restored a sort of pasture next to his house. So now that's sandy soil, as opposed to, you know, I don't know what the consistency of your soil is, but his sandy soil, when he put biochar in it, it didn't grow anything until he put biochar in it. And now he wins it regularly. And he lives in Eastham, and he always wins the top turnip. They have Eastham turnips, and they have a turnip contest every year. And, you know, he's the big winner because, you know, how he's improved his soil with biochar. And that led him on, you know, a real mission. But he's much more involved with the actual biochar. He likes the more working on the T-LUDs and, you know, the rocket stoves and everything. So he's much more on the technical side. But by a long explanation is that, I mean, he was able to do that with his soil, and it increased porosity and holding power of water.
Okay, thank you. Did you say his last name was Webb? Do you think I could Google?
Wells, Bob Wells. Yeah.
Bob Well. Okay,
Yeah,
I'll Google
yeah.
that. Thank you.
Yeah, actually, just a sec. I want to show you this. So this is the biochar revolution, and in it is Bob Wells' story, and also Hugh McLaughlin, and they're both New Englanders. Hugh McLaughlin lives out near you, and Bob lives on the Cape. But this is a real Bible, the biochar revolution.
Okay, thank you. I'll read that.
Yeah. Yeah, that is, and Bob Wells, you know, I mean, discovered biochar in one paragraph in a book, the book called 1491. In one paragraph, they mentioned how soil was restored, and that's where, in the Amazon, and that's where he got the idea, maybe I could make it and restore my soils. And boy, did it pay off for him.
Okay, thank you.
I want to backtrack to a question from Vivian. She said that we'll be collaborating with the graduate student team from the Conway School, and she's wondering if you've had any contact with the Conway School of Sustainable Landscape Design.
No, I haven't.
Okay. Thank you. And then we have a question from Karen. She said, I put a little biochar in my worm composter once a year ago. It didn't seem to hurt them much, but I didn't put much in and I haven't tried it again. I would usually add biochar to the finished worm compost, but I would be curious if anyone finds any good evidence for or against. Is that anything that you've encountered or experienced?
So once again, I don't really know about worms. But I do know that it is incredibly, I mean, there's so much research being done now about how good it is to feed to animals. My son feeds it to his chickens. And the cool thing is that, well, they think of it like popcorn or something. It's like a snack, but it's actually been proven to, help with like cow methane and stuff like that, but and take away odors. And then when it comes out, they have actually done the work of filling it with microbes and everything. So you actually can use their waste if it's got biochar in it. I mean, that's considered charged. So it's very exciting, and they've actually had some incredible results with cows, as I said, reducing their methane and also just being healthier. And so a lot of people now are feeding it to their farm animals. And I know my son feeds it, as I said, to his chickens, and they just, gobble it right up.
That's so interesting and such an interesting application. And also it seems like, so then it would probably minimize the amount that you would need to incorporate it with compost prior to applying to your soil.
Exactly. And, it sounds crazy, but, another way to help with charging it is people actually, pee on it. And of course that gives it phosphorus. So that's another way that people can charge it up. Obviously it's not giving it the microbes, but it's, but going through the animals is a good way.
Interesting. So we have time for probably a couple more questions. Does anybody want to either drop another question in the chat or feel free to just ask your question out loud? Great. So Vivian says, thank you, Debbie, for all that you're doing. I'd like to be sure that the Conway School is including biochar in their research and will include your contact info for them. Getting the school involved will have a big multiplier effect about awareness. Cool. That's great. Thanks,
Wonderful.
Vivian.
Wonderful. All of this will really help.
And Debbie, can you remind me, where are you located? I'm not sure where you're speaking to us from.
I'm in Cohasset.
Okay, yeah, so the Conway School is out here in Western Mass. I think they're based in East Hampton now. And Donna says, thank you. What is the name of the book again?
Oh, Biochar Revolution. Yep. So you can get it online. And it's basically, it is such a Bible. It tells you, all the different ways of making it. And, it's really excellent.
Thank you. Looks like a good resource. Christine, is there anything you want to add?
I had another just lingering question if nobody else has any others that they wanted to go ahead with, but I was wondering, I know you mentioned when you were going through your talk that you used coconut shells in the Amazon to make your biochar, and I've referenced other vegetation carbon sources here. And I'm just wondering, does it make a difference what carbon source you use in the end result, your end product? And can you use most things? I'm wondering, I feel like something that's kind of more herbaceous would probably burn too quickly and might not give you anything to really apply, but both what can you use, and then also if it has a result in its utility or how well it works in your soil.
That is a really good question. And once again, that comes to how, the quality control is difficult because, people are using, even if you're using wood sources, they don't come all in the same size either. And sometimes it's different woods, whether it's an oak or something like that. So you can use everything from, it's better if it has, some cellular structure, but you can actually burn algae. So you can, you could actually dry it. It needs to be dry. It has to be dry. And so you'd have to have a drying, some biochar makers actually have sort of a drying belt, that so that they can make sure that everything is dry. But you can use everything from algae all the way, to the heaviest of woods. And so, people burn. One idea that, is to have a mobile biochar maker. And when you're doing like a invasive species removal, burning Japanese knotweed, and those are some of the applications people are doing in different parts of the country. But once again, you've got to have some sort of drying ability to burn it, but they are doing that successfully. And that was one of the things I envisioned, is especially working in like a watershed organization when we're doing invasive species removal, where they recommend you burn it. If you could, actually turn it to biochar, garlic mustard, things like that. But then again, you have to adjust it because your burn level has to be different, at, the length of time. Do you know what I'm saying? So there's always tweaking and things. And that's why, people have to realize that, there are quality control and consistency. You just have to accept that it's going to be variable.
Thank you. That's so interesting, especially given that you can burn algae for it. And so applying it, so for instance, your reference to invasive species is near and dear to me as someone who's struggling with invasives on our property. And so if I yanked up my garlic mustard, I would have to, for instance, like set it out in the sun and then before I could put it in. Is that correct? Or
yes. Yeah.
Oh, thank you. We have another comment from Karen. She said, I know Kelpie Wilson has suggested a core to burn the extra dead wood and other stuff in forests. Are you familiar with anything along those lines, or is that just another possible application for it?
Oh, burning the dead wood in the forest?
Yes.
Well, absolutely. That is what should be the source material. And obviously not all of it, because we want to leave plenty of wood, for the natural occurring, for nature, but to take some out. And that's why I feel, there's got to be, some governmental regulations about it. And as far as, what people are taking out of the forests and, that kind of thing, and source material, and, that it's very carefully, what do I want to say, laid out where they got it. So I think that'll probably come, in the future. And I think that's been, there has been some concern about people, just being against making biochar as a whole, because, I think I mentioned that about, being concerned about sort of taking living trees down and things like that. But everyone I know is that is not what we're advocating. So once again, that comes with scaling, though. If you have too big a plant, you got to feed it, and then so that's why it's better to have smaller regional things where you can go cull things out of the woods, or when they go tree trim down your street, they can bring it over and burn it up, locally. I mean, that's the ideal, that it's all local, and and we are going to make an impact on our climate change.
Yeah, excellent. Thank you. Any final questions for Debbie, either in the chat or that folks want to ask out loud?
I have another question. I feel like I could probably talk about this with you for hours, but I don't want to dominate if there's somebody else who has a question also. So
I forgot to introduce Christine. Christine is our resident soil health expert, so she probably has a whole string of questions, but go for it, Christine.
all right, thank you. So this one's actually more kind of related to the larger scale application of it, and then also along the lines of what Kevin was asking with whether there was another use for the heat or the carbon dioxide that was emitted as a result. And I know you mentioned that China is creating some large scale facilities, possibly part of their infrastructure. And I was wondering, have they explored, or are you aware of any applications of capturing the heat that's created as a byproduct and utilizing it either just for another fuel source, for another purpose?
Well, I will say that most biochar, gurus or basically want to, I mean, they don't like when, that the heat is lost. So a lot of them are, really encouraging. I know, like Bob Wells on the Cape. I mean, he's actually has built a system down in North Carolina that it's a smaller scale thing, but that there's a big lumber drying facility, and so the heat goes there. It can go for greenhouses, or you can actually get that biogas. So you can, depending on how you adjust it, you can get different byproducts of energy. So you can get raw heat. I went out to his place in Eastham, and he had done one for his house, and he was getting electricity from it, he was getting heat from it, and he was getting biogas. And he was burning old blueberry bushes, and once again, the feedstock is diverse. So, but it was really exciting because, this was his goal as somebody who is trying to, develop the best kinds of ways of, building equipment to get the different resources. So I've got pictures and, of his, of the machine he created, and yeah. And then I got a biochar maker from him on a very small scale, which I would take around and show people how to burn it. Not like the T-Lud that I showed you, the real short one. This is a little bigger, and you can take it around, and it's really cool to watch how you can watch how the air flows in it, and and you can control so that there's no smoke coming out. And and basically it's like literally the air burns, I mean, when you make it, and then so that the carbon is left intact. It's very fascinating. And I'd be glad to bring it somewhere and do a demonstration, show how people can look in it and see how it works. So.
Great, thank you. And I did post your email again in the chat. So that's about 2 chat comments back if folks want to contact Debbie directly in future. So thank you so much. This is really interesting and definitely something we want to be talking more about. So we should definitely keep in touch going forward. And we just have a few closing announcements to wrap up our business here. So Christine is going to post a couple more links in the chat. We do ask people to fill out a survey, and that gives us some feedback on this workshop. So if folks could take a moment and fill out this survey, you'll see one after every workshop in the conference. You can just give us a little feedback about each workshop. So that is linked in the chat. And once again, just a reminder to visit our vendor marketplace. We really appreciate your support, and they appreciate all your clicks on their products. And the auction's still up and running. It's kind of fun. You know, when you bid on something and then get outbid, you get a little notification saying somebody outbid you, and it can be a little competitive and kind of fun. And I don't know if there's any continuing ed for this workshop, but if people want information about continuing ed for AOLCP, it's on page 21 of the program book. And let's see, I think that is about it for today. So our next workshop session begins at 11 a.m. So we got a half-hour break, and see you all in a little bit. Thanks so much, Debbie.
Thank you.